That means, is that a good idea to do it, or is that not a good idea then? It's not a good idea because you can see on this for this one, basically means every game I should lose 5 cents. So in the long run, it's not a good idea then to play. So again, the part here is I'm making P my profit. So P is actually the actual value you have earned. That means if you don't earn anything, if you don't win anything, your profit is -1 then. So your profit here, this one I circled here, okay, this one I'm highlighting here now, it's not 0. Your profit does not start from 0. You actually lost $1. We good there? Yeah. And then, so from this one, you can actually say we have a formula here we can use. Basically, it's okay, for this one, it's like, if I want to find the expected value of some variable there, for variable, we use capital 1 here. We actually use each of this. Hopefully, good, it doesn't work up everything. See here, I basically use this variable itself, the value of this variable, multiply the chance of this one happening, and add them together. Okay, so if I write that, it's basically, this sign here means like a sum. So okay, so for this formula here, it basically means I use x1 times p x1 and then plus x2 times p, the probability of the second, okay, second one here, and then continue, add them all there. Okay, again, sorry for my writing. I should have brought my pad, but once we have this one, let's now okay. Good here? Yeah. Okay, let's see. See here, now we do another, I think the question is actually quite makes lots of sense, but let's see here now, we have a discrete variable function, and let's see, it looks like this way. Okay, so this is x with small x, that's p here as well. This way, let's see, we have 1, 2, 3, 4. So for example, this could be a spinner, and the chance of them happening is let's say every time is this one is it's a bit uneven spinner, 20%, 20%, 20%, and 40%. Okay, so you could actually work out the expected value of x quite easily. Do we agree? Like this one is easy. So that would be 1 times 20%, plus 2 times 20%, plus 3 times 20%, plus 4 times 40%. Make sense? Yeah. But sometimes the question could give you this one that say, maybe let me write this one here then. Plus 2 times 20%. I find the average 20%, and plus 4 times 40%. Okay. Sometimes the questions can give you something like this. And let's see if I have this one. It's a bit like some algebra going on there. So for this one, basically means you now have a new discrete variable table there. For the expected value of 3x, it just means, now imagine I have 3x on top. That means it's 3, 6, and 9, and 12. So my answer would be 3 times 20%, plus 6 times 20%, plus 9 times 20%, plus 12 times 40%, right? Yeah, because I'm doing this way. Now everyone have a think, What's the relationship between these two things then? What's the relationship there? The second one, expected value of 3x is actually 3 times the expected value of x then. So that gives us one formula we can use it. Basically is if we have inside of this one, if you change something here, oh no. If you do something there, you can either do it as I write them down directly. Okay, you can say basically what I did here is I just write down what it is. I find x squared. I find the new variables values. I find the values of the new variables, which is x squared, and then continue. You find the new variables and then do the multiplication and continue. Or I could also do it if this one is linear. Okay, again one. If this one is linear, as you can see here, I can also do something like could I rub the last line out? Yeah. If this one is linear, I could also do e of k x. I could also do k times e of this one as well. Okay, because every one of my value is, for example, doubled by 3. That means in the end, my average is doubled by 3. It's the concept of average. If my previous values, everything is doubled by 3, that means definitely it's going to be doubled then. However, everyone have a think about this one. Would this be correct? Really, it's average. So like now, if like now I'm playing a game, it's 1, 2, 3, 4 chance of winning. But then other people said, if you go to my game, you have 3, you can win $3, $6, or $9, or $12. That means like your average is definitely going to be 3 times more than the previous game store or something, then, right? But for example, now if someone says, okay, I'm going to give you squared then. So see here, this one, they give you squared. That means it's going to be 1, 4, 9, 16. Have a think. If they give you squared, is there any quick method I can do it then? Could I do it as e of x here and square it then? Could I do that way then? Think about it. Could I just use my previous expected value of x to square it? Have a guess. Could I do that? You actually cannot, because it's more like, it's a bit odd to think about this one. But your numbers, because your numbers here not increased by the same ratio here. You can say 1 to 1, 2 to 4, and 3 becomes 9, 4 becomes 16. Everything, the ratio is different. So you cannot find a general pattern for your average then. Okay, so this is this one. That means now if we do a practice of one question, let's say that's actually oh. See here. See here with this one. Let's do 1, 2. Let's do just one easy one then. And 1, 2, and 4. And let's make this one as x squared. Okay. And the other one we can do 3x plus 1 then. Okay. So x squared would be 1, this row here, 4, 16. And 3x plus 1 would be 4, 7, and 13. Okay, and let's now give them some probability then. So probability of x equals to x here. That would be, let's just do 0.5 0.3 and 0.2. It feels like now imagine you go to a game store and you are playing a game. So the first store told you like, oh, if you play at my place, if you spin a number one, and the chance is 0.5. If you spin two, like maybe it's $2, the chance of getting $2 will be 0.3%. And if you want to get $4, the chance will be 0.2 then. Right, that's the first store you go to, and then you also have other stores as well. So now the second store you go to, like they said, oh, okay, it's going to be squared, like 50% of chance you get $1, and then 30% of chance you get $4, and then 20% of chance you get $16. And the other shop said, I do this one for you. Okay, so we are now going to work it out and see the expected values and then find the pattern then. I know for this one, that's the easiest one. Plus 2 times 0.3 plus 4 times 0.2. Could anyone find the number? 0.5, 1.9. 1.9 there. Okay, so if I do the square, I know this one would be 1.9 squared, so roughly is 4. So I'm not going to use try this one. So now I don't, you do it properly. So second one, x squared, like, x squared now is my variable now. That means to this stop, I actually look at this row and this row here. Does anyone give me the equation? What do I do? That basically means you now have 50% of chance getting a 1 because your variable has changed into 1 squared is 1. 30% of chance getting which variable then? Okay, which value? 4. And then 20% of chance getting 16 then. Because as a game has changed, the outcomes have changed as well. So 1 times 0.5 plus 4 times 0.3 plus 16 times 0.2. If you look at this one, would anyone think like, oh, the bottom one is square of the top one? No, right? It doesn't have any, it's a combination of both like linear and non-linear. So you cannot have any patterns to it. You have to work out the values of this one. You have to work out the values of these ones here and then continue. Okay, so for this one, we pass it here, then we don't need to work out the value. But next one, see here, I'm going to do this one. And 3x plus 1 here equals 2. Let me rub out this one because I don't think we are going to use this one at all. Okay, this one is 4. For this 4 times 1, it's basically 3 times 1 plus 1 and then times 0.5 plus 3 times 2 plus 1 times 0.5. If I rewrite it, and plus 3 times 4 plus 1 times 0.5. Okay, once you have that one down, you'll find, okay, everyone have a look. What's the relationship between this expected value and the one we have now? Oh, sorry, my bad. What am I writing here? It should be times by 3. Times by 3. And this one is times by 0.2. Okay. If everyone think about this one, if I expand the brackets, what do this part give me then? Have a look at the maths there. For the yellow part, okay, I'll do it on the TV then. For the yellow part, I've highlighted. This is 3 times 4 times 0.2. Oh, sorry, this one start from here, this one. 3 times 1 times 0.5. That means it's 3 times bigger than this part. Right? And this part is 3 times 2 times 0.3. It's only look at this yellow part. It is actually 3 times bigger than this part as well. And this part here is 3 times 4 times 0.2. It's 3 times bigger than this one as well. Yeah. So everything now is 3 times bigger. And then I look at again, what is this decimal doing then? 0.5 plus 0.3 plus 0.2 gives me 1. Okay, and that 1 equals to this one as well. You have to think about this one basically is, every other variable, they give you $1 more. So that means definitely in the end, your average is going to be $1 more than. So the idea is average, like your average, everything is tripled. That means my average is going to be tripled. And if I add a 1, imagine everyone here grows more than 1 centimeter than before. That means the average of the whole class is going to be 1 centimeter taller as well, right? So this one here is actually, again, sorry for my notes, is actually 3 times it and plus by 1 then. Okay, so again, if you understand this is average, like, if every person's height is going to be tripled, that means the average height is going to be tripled as well. Everyone's height is going to be shorter with 5 centimeter. That means our average will be shorter with 5 centimeter as well. Okay, so can I delete this part here? Yeah. But again, for squares, you cannot do it because every value is different. You don't know the effect. And okay, so the formula would look like this way. Should be fixed. This would make a lot of your working out handy than before, because you can then okay, now let's have a look at this question together. And have a read of this one. And mark the row as well. Jeffrey, how about your homework last week? How about your homework last week? Oh, we did not have homework. Oh, yeah, we did it in class.
Yeah.
Really? I think last topic was not very.
Oh, we did.
Okay, the teacher? Homework? Oh, you were not, you were here first lesson. And me is here. And Shreya is here. Yeah. Kevin. Yeah. Shreya is here. Yeah. Okay. Let's have a look at this one then. It says it's actually the question you can use, right? For 5 monthly, maybe Kevin, could you please read the question?
Guarantees customers are completion with doesn't miss the probability that a customer will require one service all in one that's 0.45. The probability of 2 calls is 0.01 and the probability of 3 or more calls is 0. Each call cost the repair company $40. What is the TV repair company's expected monthly gain?
Yeah. So see here, this question is, if we read this one again, it basically shows like, for a $5 monthly fee. That means they are going to charge the customers with $5 every month. And the customers can call them then. If they receive a call, they have to fix it. So, and then the fixed fee is every call would be $40 then. So the question is asking you from the company's perspective. It's not from the customer. It's asking you, is this a good deal or not? Am I going to offer this one or not? So have a think. What should my X be then? You need to set up your variable here. 5? What is the company's expected money gain from this one?
1, 2.
Yeah, I could just say here, okay, let's see here, this one is, let me think. See, this one actually, have different ways to do it then. Let's do 2 ways then. Do you guys, which ways are we thinking? Because we need to set our table and then do the average and stuff, right? Which way are we thinking then? Which way are we thinking? We can either do this 2 ways. We'll do two. Anyway, it's thinking about something. It really depends on how you set up your x. I could do and let x be the monthly gain, right? Yeah. So I now set up a table here. So my x equals to x here, and sorry, my bad. Okay, let's see here. If I receive 0, 1, first one is require 1 call. If I get 1 call, how much do I gain then? If I get 1 call, it's negative. If I receive 1 call, that is $5 I gain, because basically I gain $5 and I lost $40. That means it's negative 35, and it's 0.05. Okay, and then 2 calls. If I receive 2 calls, how much do I gain then? Negative 75, because I earned 2 calls. I basically need to fix two TV. So that is means I need to use $80 there, but I only can charge them $5 for the monthly fee. That means I lost this one. That is, what's the chance of this one? 2 calls is 0.01. Okay, and last one, 3 or more. You guys now see the problem then. If I have 3 or more calls, could I actually list this table here? 3 or more. How much would I cost then? Because it could be 3 calls or 5 calls or something then, but I cannot find the value here. I could receive 10 calls. Oh wait, 3 or more is like a 0. That means it's fine then. This one is 0. That means I don't even think about this one at all. Okay, 3 or more is like it's fine. I don't need to work out this one. I cannot work out this one either. What's the rest then? Again, what? 3 or more. Remember, I cannot work out the monthly gain because I don't know if that's 10 calls or something. But luckily it says it's 0 as well. So last one. What's the last one then? The probably do not add up to 1. So what do I do then? You can see we talk about 1 call, 2 calls, 3 or more, and 0 calls. If it's 0 calls, how much do I gain then? $5. And then that probability is 0. What's the probability then? 4. They add together should give you 1. So up to here, everyone, you can work out the yeah. Could you guys work it out then? Got the answer?
2.2.
2.2. Positive?
Yeah.
Yeah. Is that a good deal or not a good deal? Yeah, it is, because you actually gain a profit from this one. So it's a good one. This is one way to do it. Any other ways to do it then?
Sure.
Yeah, true. It's actually quite helpful, right, to know this. But with think about in real life, it's more complicated than this one, and you do some modeling and statistics as well. Any other ways to do it then? My X now is a monthly gain. Could I set my X as the number of calls then? Could I do that? I then work out the average number of calls I receive as well, something like that to continue, right? So for example, I could do it in another way. Could I rub this out? Yeah, almost there, and I'll give you some time to do your own practice. So I could let X be the number of calls as well. X be Jack, are you doing your work there?
Yeah.
Seem really busy. The number of calls. Okay, so now I have this one here. So X, capital X equals small x there. Okay, one call is 0.05. Two calls would be 0.01, and zero calls would be 0.94. Okay. Once I have this one, I could work out how many what's the number of average calls I get. So that's 1 times 0.05 plus 2 times 0.01. That is 0.07, right? So this one is 0.07. Have a think, everyone. With this 0.07, what do I do then? How do I link this 0.07 with my previous ways face together then? Yeah, maybe think in this way. The number of calls. See here, this is my gain, right? My gain, can anyone give, I can think about like what's the relationship between the number of gains and the number of calls I received? Because every person I can get $5. Okay, so 5 then. And every call would cost me $40. So would that be, for one person there, would that be, 5 is my monthly fee there. And subtract every call costs me $40. It's 40 40x. Okay. $5 is the money I get. And then $40 is the money I lost for each call then. So imagine everyone, X is the number of calls. I don't know how many people are there. So for each person, I can charge them $5 only for a month. And then you can, in 1 month, they can call multiple times. So every time they call, I need to pay $40. So that's 5 minus 40 then. What are they are with this one? Yeah. Yeah. And then I can use the rule we learned before then to do it. So the rule we learned before, that would be, I then have this one, 5 minus 40x. How do I use this rule then? Everything is increased by 5, but everything is also negative number as well. So that means it's 5 minus 40 times 0.07. So that would give me the same answer then. Which way do you guys find it easier? Yeah, I feel so as well. I think first one makes more sense. Okay. Yeah. Okay, once you finish, you guys do some practice yourself then, before you continue. Is 13 the question 1. You don't need to write any working out, everyone. You can just do it on your calculator and then check the answers at the back of it. 3, yeah. Okay, do 7 as well. 3 and 7. Yeah, again, you can use your calculator to press the button directly. And once you get this one correct, you can then yeah. Thank you.